purpose of this video is to begin to explore the relationship between perpendicular lines and slopes. And I want to start by talking a little bit about this symbol that we see here, this upside down T. That upside down T symbol in geometry actually means the word perpendicular. More important than that, though, is to know what the word perpendicular means. You hopefully recall from your middle school geometry years that perpendicular means forming right angles. And if you didn't remember that from your middle school year, it's time to commit that to memory. That's an important thing to know. So perpendicular means forming right angles. Now, just like parallel lines had a special relationship with the slope, perpendicular lines have a special relationship with the slope also. Perpendicular lines have slopes that are negative reciprocals. So I'll give you a minute to write that down on the line, and then we're going to talk a little bit about what negative reciprocal means. If I had gotten to make this vocab word, I would have called it opposite reciprocal slopes. But I didn't get to make up the vocab word. So what does this mean? This means that these fractions or these slopes will have opposite signs. So in other words, one of the slopes has to be positive and the other of the slopes has to be negative, which makes sense. If they're going to form right angles and one of them has a positive slope, the other line would have to have a negative slope in order to form that right angle and therefore be perpendicular. So that's the first criteria that has to be met. The other criteria in order to be a negative reciprocal is that you're going to flip the fraction. So in other words, if one of my slopes was a positive 1/2, then the negative reciprocal of that would be a negative 2/1. So this positive became negative, and I took the numerator and denominator of the fraction, flipped them around. So again, opposite signs and flip that fraction around. Okay, in number 1, they give us some ordered pairs, and they're asking us to explain whether or not line AB is perpendicular to line CD. So in order for these to be perpendicular, their slopes would have to be negative reciprocals. So what I'm going to do is I'm going to go find the slope of line AB, and I'm going to compare the slope of line AB to the slope of line CD. And if those two slopes are negative reciprocals of one another, I will know that the lines are perpendicular. If they're not negative reciprocals, I know the lines are not perpendicular. So I'm going to go ahead and I'm going to start by finding the slope of point A or line AB. So slope, remember, is either y2 minus y1 over x2 minus x1, or change in y over change in x. So I've got a slope of 5 subtract 9 over 1 subtract 3. And I'm going to grab my graphing calculator, and into my graphing calculator, I'm going to type the fraction whose numerator is 5 subtract 9 and whose denominator is 1 subtract 3. And when I do that, my graphing calculator tells me that that line has a slope of 2. I'm then going to go do the same kind of idea for the line that contains points C and D. So the slope of this line is 2 subtract 6 over 2 subtract 4. And when I type those numbers into my calculator tells me that this line also has a slope that's equal to 2. So as far as an explanation for whether or not the two lines are perpendicular to one another, no, they are not perpendicular to one another. And the reason for why not is that their slopes are not negative reciprocals. Just for giggles, if that symbol had said parallel, then the answer to my question would have been yes, those two lines are in fact parallel because their slopes are the same. So it's important to differentiate between parallel and perpendicular. In number 2, they're asking us to write an equation of the line passing through the point with coordinates 2, 3 and perpendicular. So again, when we see the word perpendicular, we think negative reciprocal slopes to the line whose equation is y equals negative 2x minus 5. So the slope of this line is equal to negative 2, or negative 2 over 1. The slope of a line that's perpendicular, and notice I'm going to use that m in the subscript for perpendicular, is going to be what I get when I take the opposite sign, so positive, and flip my fraction around, 1/2. So I now want to write the equation of a line that passes through the point with coordinates 2, 3, and using the slope of positive 1/2. So I've got my y minus y1 equals m times x minus x1, or in other words, y subtract 3 is equal to 1/2 times x subtract 2. And just like when we used this form of a line earlier, that's done. It's finished. It's time to call it a day and stop and go on to the next problem. All right, so in moving forward here, write an equation of the line passing through the point with coordinates 1, 5 and perpendicular to the line whose equation is 3x or 3y is equal to x plus 15. I'm going to go ahead and first of all find the slope of this line by putting it in the form y equals mx plus b. So my slope here is my positive 1/3. And just like I did before, I'm going to still use m for slope, but now I'm going to use that little upside down t in the subscript, meaning the slope of a line that's perpendicular. Well, this guy has a positive slope, so my negative reciprocal is going to have to be a negative slope. And then I'm simply going to flip-flop the numerator and denominator of my fraction, making that perpendicular slope equal to negative 3. And again, I've got y minus y1 is equal to m times x minus x1. And I'm going to use the point with coordinates 1, 5 and that perpendicular slope of negative 3 over 1, or just negative 3. So my equation now becomes y subtract 5 is equal to my perpendicular slope of negative 3 times x subtract 1. And at that point, we're done. As always, take a few minutes and in your own words summarize the important understandings and the things you're going to need to remember to be successful with the problems involving slope and perpendicular lines, and then see if you can apply what you've learned to answer the questions on that next page.